For this part of the balancing, we're going to be looking at combustion. Everything is still based on Lavoisier's conservation of mass, so we're still using coefficients to multiply our atom amounts to make the atom amounts equal on both sides of our yield. Yes, we're still reactants yielding products. So I want to take a look at this next problem. It's pentane burns. Pentane, if you remember, pent stands for 5 carbons. To find the hydrogen, you take carbon times 2, so 5 times 2, and then add 2. That will give you 12. Whenever you see the word burns, that means we're going to add in oxygen gas. It is a diatomic, so don't forget the 2. And then to get our products, when you see the word burns, that means that it's carbon dioxide plus water. Now we want to go through, we'll make our list. And for this one, we've got 5 carbons, 12 hydrogens, 2 oxygen. Over here, there's 1 carbon, 2 hydrogen, and being careful, we have 2 oxygen here, 1 over here. That gives us 3. Start off with your carbon. I have 5 on the reactant side, 1 on the product. We're going to go ahead and put in a 5 by my carbon dioxide. That will give me 5 carbon. Now it does change my oxygen. I now have 10 here plus my 1 here. That gives me 11. To fix the hydrogen, I have 12. In the products, I have 2. So I'm going to multiply by 6. 6 times 2 gives me my 12 hydrogen. Now this also changes oxygen, so I need to recount these. I have 10 in the carbon dioxide plus 6 in the water. That will give me 16. To fix the oxygen, I need something times 2 that equals 16 and is a whole number. That answer is 8. And that gives me my 16 oxygen. We are balanced. Now, there is a trick to combustions. I want to take a look at the second example here. We have hexane. Hexane stands for 6 carbons. If we do our pattern again, remember C, number of carbons, Cn, and then our H2n plus 2. So if n is 6, 2 times 6 is 12, plus 2 gives me 14. Then we have our oxygen, because again it's a combustion. Don't forget the 2 for the diatomic. And then we've got carbon dioxide and our water. So for this one, we want to go through, make our list. Carbon is 6, hydrogen 14, oxygen is 2. Over here, carbon is 1, hydrogen is 2, oxygen is 3. So we want to go through and start our balancing. As we do this, take a look. I've got 6 carbons, 1 here, so we stick our 6 in. That now gives us 12 oxygen plus 1 is 13. Hydrogen, 14, 2, so I need to put a 7. 14 hydrogens. Now, when I look at my oxygen, I still have my 12 plus 7 more. 12 plus 7 is a 19. Ooh, what times 2 equals 19 and is a whole number? Nothing. This time, we are stuck. To get unstuck, you're going to need to do a process simply of doubling. So we're going to go through and we are going to double our coefficients. To do this, we're going to add a 2 in the front. Our 6 will now become a 12. Our 7 is now a 14. And we want to go through and recalculate our numbers real quick. 2 times 6 gives us 12 carbon. 2 times 14 will give us 28 hydrogen. Over here, 2 times 1 for the carbon is 12. Hydrogen is going to be 4 times 2, 28. Now my oxygen, 2 times 2, 24, plus 14 times 1, that's 14. 24 plus 14, 38. Now, what times 2 equals 38 and is a whole number? That is 19. Notice, looking at my coefficients now, they cannot be reduced, which means I have found my lowest ratio. I have everything balanced on each side, so we are finished.